Okay. Now, can you believe how time has flown here? Yes. You can. Okay. Well, time doesn't seem like it's gone by that fast to me, but all right. We're going to work with radicals now. It'll be up to you to look at the scientific notation. All right? By the way, let me ask you a question, okay? What do you think a to the 1/2 times a to the 1/2 is? A to the 1. Okay. Yeah, we can do fractional exponents. Okay. So we can do fractional exponents. And we do. So let's take a look at the definition of square root. Okay. Square root. So we say the square root of x is equal to a if a times a is x. Okay. Now, one thing we're going to be dealing with is the idea of what we call the principal root. Okay. And the principal root means that these two values have to have the same sign. Okay. So, by the way, the radicand and the radical have the same sign. Just as again, a sort of a notational note, okay, we know that a base raised to a power is what we call an exponent, right? Okay. So in here we have a radicand, and there's an index right there. Okay, is a radical. Okay. So, with that in mind, then the square root of 9 is equal to 3, since 3 times 3 is 9. The square root of 5, okay, well, I don't have a nice number that can go with that, do I? No. What kind of number is the square root of 5? Irrational. Perfect, okay. But square root of 5, okay, is equal to the square root of 5 since the square root of 5 times the square root of 5 is 5, right? Okay. So let's see. How about 5 to the 1/2 times 5 to the 1/2? It's 5 to the 1, which is just 5, okay? So take a look at this. and tell me what you see there.
The fraction represents a radical.
The fractional exponent here represents a radical, doesn't it? Okay? And so I note that the square root of x is x to the 1/2 power. Now, essentially, radicals and exponents are inverse operations. Radicals undo exponents. Exponents undo radicals. They're inverses. Okay? So one undoes the other. We can extend, well, let's see, let's just use a little bit more the properties of radicals here. So let's see, if I have, now on this one you can see that if I have the square root of 9 is equal to 3, the square root of 3 times 3 is 3, right? Okay. How about the square root of 3 times 3 times 3 times 3? Yeah. You can see that's going to be 3 squared or 9, right? Okay. Let's try something else here. Suppose I have, well, let's say the square root of x to the 4th.
X squared.
X squared. Okay. What about the square root of x to the 5th?
X squared. Square root of x to the 5.
Okay. If you take a look at this, okay, I can, it takes 2 factors of x to get out, right? Because of the index. The index here is a 2, isn't it? Okay. So this is like saying that I have x times x times x times x times x, and the square root of x squared, of course, is x. Okay. The square root of x squared is x. I have 1 left in, right, that I can't get out. So square root of x, or x squared square root of x, right? Okay. Well, now let's see. So if I wanted to do the square root of 45 x squared y to the 9th, okay, what would that be?
3x.
Okay, how did you get the 3?
Because it's 45 can be broken down to 5 times
5 times 9, right, very good, okay. So we're going to be taking care of this thing, right? Okay, so that's going to, you said 3, what? X. Y to the 4th. Square root. 5y. Make sense? Okay. Now let's see. Suppose I had the square root of 45 times the square root of 80.
You can put them in the same way.
I could, and I will. Oh, okay. But let's think about this. What's here under 45? This is, you said, 5 times 9, right? And 80. Is there a square number in 80?
Yes.
16 and 5, right? Okay. So what can be pulled out? 3, a 4, and a 5. Because square root of 5 times the square root of 5 is 5. And so you can see we have 60 right there. And I didn't have to multiply those two and get 3,600 in order to do that, okay? I just started taking a look at everything right away, didn't I? So let's see here. We'll modify our square root definition, okay? And we'll go to cube root, okay? And the cube root of x is equal to a if a times a times a is x, right? Okay, which means a to the third is equal to x, right? Okay. Just to think about this situation here, a to the 1/3 times a to the 1/3 times a to the 1/3 is what? A. Okay. And the cube root of a times the cube root of a times the cube root of a, okay, is going to be a, right? So what can you tell me about that?
It's the same as 1.
Okay, the cube root of a is the same as? All right, okay. So the cube root of a is the same as a to the 1/3. Okay. And so if I was going to take the cube root of 80x to the 5th, y to the 14th, z to the 9th, okay, tell me what I would need to do there. Well, now I'd be looking for cubes, wouldn't I? Okay. And what's 80, by the way? 80 is 8 times 10, or 80 is 2 times 2 times 2 times 2 times 5, right? Okay. And can you see the 3 factors of 2 in there? Okay. So 2 would come out, and the 10 would stay in, wouldn't it? Okay, so I'm going to have a 2, and over here I'm going to start off my cube root. 10 stays inside. Okay, tell me what happens here.
X to the 3rd.
Take out 1x, and x squared stays in because 3 of these x's inside is worth 1x outside, right? Y's?
You take out y to the
4th. Y to the 4th. How many sets of 3 can you get out of 14? 4 of them. And that means y to the 2nd perfect is inside. Thank you very much. And what about my z?
z to the 3rd.
Z to the 3rd, right? That's not too bad either, is it? Boy. Well, that, okay, I'm going to claim my watch as being more correct than that. My watch says we have 3 more minutes. Okay. Now, tell you what, let's do something a little tricky here. We're going to talk about, okay, now, if we were going to just talk about a general root, the nth root of x is equal to a if a to the nth power is x, okay? And so the nth root of a is the same as a to the 1 over nth power. Okay. Now, let's suppose that you wanted to take the square root of 3 times the cube root of 5. Does that look a little different?